Awesome. So first and foremost, I actually have the slides up on slides.com, and I believe I've shared the link in the local chat with John. And if he would be so kind, he could share that link to everybody. And you can actually watch the slides as they move locally on your computer if you happen to be on a computer.
I just posted it to YouTube. Let me verify on my end. Oh, yeah, there we go. Great.
Perfect. Yeah, so you should be able to follow along as I go through the slides. And today's talk, I wanted to talk about aspects of great testing software. Now, that's just a play on words because the name of my testing framework is as-pect. And I wanted to share the first journey I took through WebAssembly. Maybe it's not the first, but it's definitely the first big one that I definitely trudged through. Yeah, so let's get started. Who am I? My name is Josh. I'm Joshua Tenner, and I'm the senior web developer at the Husky Dental program, and I'll share a little bit about that in a few seconds. I'm a husband.
Hey, Josh, before I cut you off, are you screen sharing?
Oh, cool. So I should actually screen share the thing here.
Yeah, I might as well.
All right, just let me make sure. Is it working?
Yep, I see it.
Perfect. All right, cool. So this is the most important slide. This is my family. All three of my kids, Alice, Aaron, and Ian, they're right here. The one in the bottom right is the loudest, and he's the most awesome. And my wife's there in the middle. I am also a Girl Scout troop leader, and I think my Girl Scouts are watching tonight. So shout outs to all of them. Let's see. And I work for the Connecticut Dental Health Partnership. Now, the Connecticut Dental Health Partnership is actually the Medicaid program, and we're contracted out to actually perform the dental part of the Medicaid program. And with my work experience, it's been about, 7 years now where I've been doing solo DevOps at this company. And my motto is automate as many things as possible. And it's been an absolute blast. I'm also a full stack web developer, and I do desktop software and back-end work. I'm basically a jack of all trades. It's a lot of fun. And of course, I figured we should start off with an agenda and actually talk about what this talk will be about today. Today, I want to go over WebAssembly, what it is, especially for people who don't know what WebAssembly is. Then I want to go over what AssemblyScript is, how I started with it, and what my testing software is, and how to actually get started, which will be followed up by a live demo where I'll actually bootstrap an entire AssemblyScript project right here in the browser, and you can get started today too. So let's definitely do that. So let's definitely go over what WebAssembly is. WebAssembly is a lot of things, but mostly it's a compile target. And what you want to do is you want to take your code in your language and then compile your code to WebAssembly so that it can run in the browser. Or in a lot of other people's cases, there's places where you can run WebAssembly that isn't the browser. And it's comprised of a whole bunch of very special bytecode instructions that resemble math, bitwise operations, loading and storing data from linear memory, and SIMD. The number types that are supported in this language is 32-bit and 64-bit floats and integers. That's both of them. And as an end result, it allows you to actually get very, very consistent performance for heavy CPU loads in the browser. It's very, very powerful. And that has a lot of meaning to people. In fact, a lot of people decided to get up and actually, create their own compiler. And of course, I'm actually talking about AssemblyScript. AssemblyScript is a TypeScript to WebAssembly compiler. And it's wonderful for heavy CPU loads. It allows you to handcraft very, very fast and predictable performant functions that run inside the browser using a language that you're very familiar with as a web developer, especially if you use TypeScript. Of course, it comes with a couple caveats, like you have to write your own glue code. And what does that mean? It means that you have to actually tell the browser how to communicate with the linear memory inside of the WebAssembly module. And that takes a little bit of time to learn, but I highly recommend learning how to do it. And once you're done actually figuring out how to work with WebAssembly, you can publish a module to NPM and everybody can get all of the benefits of all the software you wrote very, very quickly. All right, so now that we know what WebAssembly is and now that we know what AssemblyScript is, I'd like to talk about where I started. It was about a year and a half ago when I finally decided that I wanted to start actually building stuff in AssemblyScript. And there were a lot of reasons why I decided to do that. One of them was I wanted to build Canvas applications and do very, very fast request animation frame loops to get like predictable performance in 16 millisecond frames to get games in the browser. And what I got instead of very, very fast performance was very, very consistent performance. And it's gotten better over the past year and a half, which is great. Let's see. Of course, there were a bunch of other problems that I had with it because there was no real good way to actually test my modules. So if I wrote AssemblyScript, I didn't have a really good way to bootstrap my modules in a testing framework. And since I loved building tools, I figured why not just make a quick and dirty testing module for AssemblyScript? And better, I could actually replicate some of the more popular testing frameworks. What ended up happening was I decided to take Facebook's Jest and then port it to, excuse me, I'm having a frog in my throat today. I ported it to WebAssembly and AssemblyScript. And the end result was a very familiar web dev experience. It's like you installed TS-Jest and TypesJest and wrote all your tests inside of TypeScript, except it's actually an AssemblyScript. And it was very successful. I also wanted to talk about what I meant by familiar. Most JavaScript developers who actually write their own tests will write in a syntax that looks exactly like this. They want to describe a group of tests and then create their tests and then perform some kind of expectation to see what happens with their code. Make sure that it works the way they want it to. So this compiles in Jest. This definitely compiles in as-pect today, and it's great. Of course, this came with its own roadblocks. And one of the things I noted was I can't actually run AssemblyScript modules through Jest because AssemblyScript has a slightly different standard library, and it has a slightly different low-level set of functions that you can use to access local memory, for instance. So it was hard to mock load and store functions directly. And of course, when you had to actually bootstrap the compiler into Jest, it ended up becoming a nightmare because you have to load the compiler and then compile your binary and then run the tests. And Jest didn't really like that very much. So it was time to actually start making something brand new. I ended up making a test framework that actually tested itself, which is great. So all of the expect functions are actually tested and bootstrapped by my command line today. And it actually uses Jest for a snapshot output to verify that things actually work the way they're supposed to. So let's actually build this testing framework from scratch, and I'll show you all the individual parts to see how it works. as-pect was much like the process of inventing the light bulb, where you need to fail at creating a light bulb numerous times before you can actually start at getting a light bulb to work. It's a very common phrase, turn of phrase. I'm probably not saying it right, but that's okay. So let's actually go through those things. So what do we need? WebAssembly is one of those languages that doesn't have error handling yet. And what I mean by that is that it has a very special instruction for causing the stack to unwind. And what it'll do is it'll halt execution of your code, unwind the stack, and then when the function hits the point where JavaScript call it, it will throw an error. And it's an unspecified error, so you can't really figure out exactly what happens. So what we had to do is we had to, we had to call out into JavaScript with a string that describes the error, unwind the stack, and then throw the error. And here's how we do it. Let's see. as-pect has a very special function called the trycall function. And this very special trycall function accepts a function pointer. This is actually a number. It's not a function reference. Like you can't just pass a function reference around in JavaScript pointing to WebAssembly. So what I had to do was I had to actually write a very special function called a call function, and then actually physically call that function pointer manually. And then if there is an error, we'll catch the exception and then pull the stack trace out of it and store it inside of the test context here. So this is actually JavaScript, and it's glue code. And what it does is it wraps around the WebAssembly module to try and call the function. Now, what does that call function look like? This is actually very, very simple. This is AssemblyScript code. It looks very familiar. It accepts a callback, and then you just call it. Very simple. Of course, you pass in a number to WebAssembly, and it treats it like a function reference. It's great. I would imagine that showing this function to junior developers, it would actually be very easy to explain what it means, simply because it's written in TypeScript. And this is taken directly from my source code, by the way. So now that we have a way of calling functions inside of AssemblyScript, let's actually build an expectation class. And this expectation class actually describes the nature of the test itself. It'll have some kind of actual value. And the way you pass in that actual value is by using the expect function here, and it returns a new expectation. So it'll perform a heap allocation and store the actual value on the heap. This is essentially the guts of the expect function that you've come to know and love as developers if you're a TypeScript dev and you use AssemblyScript, if you use TypeScript and Jest. And now that we actually have an expectation, we can actually perform a comparison. So for instance, the to be comparison actually determines if the values are equal. So here we have the to be assertion. We have some kind of expected value, and it's of type T. And also, additionally, a message that can possibly be sent up to the host if the assertion fails. And we'll go over the steps of how to actually determine if two values are equal here. The first thing that we do is we perform the double equals operator here on line 7. And we check to see if the expected value equals the actual value. Then we turn it into a number, an I32, which is an integer 32-bit number. And it'll either be 1 or 0 because it's a Boolean value. This is something special to AssemblyScript. But this actually becomes useful later, and I'll explain why. Then we report the actual and expected values. And here on line 10, we actually assert that the values are equal. Now, it's also possible to use the not property and then actually negate the assertion. And what we're going to do is we're going to determine whether the values are equal or if the assertion is negated. The caret operator in between them is the exclusive OR operator. And what that means is one value is 1 or the other value is 1. Otherwise, the assertion fails. And then it reports the message up to JavaScript and then displays an error on your screen if the expectation failed. And finally, if everything passed, we clean up the actual and expected values. And of course, there's these functions here, the most important functions. These are implemented by JavaScript. the describe, the test, and this particular throws function. I'll explain what that does in a second. Here, the describe function is just some function that JavaScript implements that allows you to describe a group of tests. And you pass it a callback and a description to describe what the group's name is. There's also the test function, which describes a test, for instance. And these are all global functions that you can access just like Jest has them. There's also this magical throws function here, which is a test that is designed to fail on purpose. That means that we expect this particular test to throw an error on purpose. And that's actually useful for testing things like assertions, and I happen to use it a bunch in my own personal testing of as-pect. Oh, look, there's a question here. So does it support Jest's full mocking API and their auto mocking features? No. So there's a bunch of things that aren't implemented in AssemblyScript yet that would make stuff like that possible, like closure. Closure just doesn't happen to be supported yet. And there's a pull request open in process to actually get closure started. And I believe it would be possible to do the Jest full mocking API to actually detect to see if a callback function was actually called. However, at the moment, no. One of the most important parts of this framework is how the test algorithm works. And not a lot of people actually implement test collection algorithms, but they're pretty simple. The idea here is that this describe function here represents a test node, and it's a group of tests. And inside it are each individual test that shows up inside of the group. So for instance, a test, a second test, and a third test are actually children tests of some tests, which is the group here. The way that the test algorithm works is it calls each describe function and then says, okay, do I have any children? If so, then I loop over all of the children and actually call those callbacks. If any of those tests fail, the group also fails. And you, this isn't exactly obvious to you, but you can actually have tests inside of tests. And I've seen some Jest code bases that have this. Implementing this particular algorithm was a total nightmare, and I believe Bill was in the chat. He watched me have a whole breakdown about it. It was a lot of fun. So this is the part where I actually go out of my comfort zone and start doing a live demo. And hopefully the live demo gods won't blow up on me today. Let's start the workspace here. I actually have a Git pod here, and anyone following along can click on the link on the screen right now and actually get a live version of the repo that I'm currently using here. I just have to tell it to share my screen correctly. Let me see, there's the Opera tab.
All right, we're seeing your Git pod.
Perfect. I don't know if this is currently working here. Let's see. Huh. I can't see the files. The live demo gods have shamed me. Yeah, it doesn't seem to be doing the thing here. I'm actually going to close this out really quick and then try again. Everyone feel free to chat in the chat and see what's going on here, because I definitely don't know what's going on.
Any Git pod experts out there? Anyone who's run into this before?
Oh, create a fresh workspace. Here we go. Let's see if this does the thing.
All right.
Yeah, I just want to see the file structure because that's useful. I can work from the command line without it, but oh, perfect. Here we go. Let me share my screen now, and everyone can see what I'm doing. Opera tab.
Oh, we see files, we see Git pod, we see command line.
All right, so we went off without a hitch, right? First things first, let's take a look at our freshly npm initted software here. We're going to actually change this package version because I just actually updated it. So here we have a few development dependencies. We're going to install AssemblyScript, and we're going to install as-pect, which is my testing software. You can see how easy it is to get started. Let's see, npx as-init dot. Ooh, I can spell, guys. All right, here. So this simple command will actually initialize your AssemblyScript project after you run npm install, because we don't have any node modules here. So let's start with that. And voila, we're already all set. There weren't that many packages to install, and I believe a lot of them, only 36. So that's actually pretty good. We're going to as-init, and what that will do is it will scaffold an AssemblyScript project for us. And here it lists a bunch of directories. It creates a tsconfig, an index file, a build folder, a whole bunch of other stuff. And all we're going to do is we're going to say yes. And voila, we actually have an AssemblyScript project up and running. The biggest thing that you'll want to see is how to actually bootstrap your AssemblyScript project here. So let's expand this out nice and here. Okay. So all we're going to do is we're going to read a file, which is the WebAssembly file that AssemblyScript will generate, and it will output our module for us, which is great. It also generated this tests folder, which I'm not entirely sure what it's used for, but if you want to test your software from JavaScript to see if everything works nicely, you can actually use this file. But for today, we're actually going to delete this folder because we're using as-pect to test our stuff. The next thing that I want to show you here is the assembly folder. Okay, let's save this. The assembly folder contains your AssemblyScript module. And as you can see here, this looks like a very simple add function. We're going to just return a plus b. Noted here, we have an i32 type, which is alias to number here in the IDE, but it's actually a 32-bit signed integer, and it gets treated that way. Most developers who use Rust will know this number type very, very well. So knowing that we have an add function here, let's actually generate a test to make sure that our add function works. And the way we do that is we have to bootstrap as-pect first. So what we're going to do is run the asp command with the init flag, npx asp init. And as-pect doesn't ask you, it just generates a couple folders here. So it actually generates a tests folder, which should be familiar to Jest developers. And it generates a types file, and all this is a reference to the as-pect types. And finally, it'll generate a bunch of actual tests. So let's see if I can make this a little bigger so that people can see it. We're going to do everything from scratch today. We're going to add two numbers together. And the way we're going to do that is we're going to create a describe block, is what I call it. We're going to describe addition and pass it a callback. And then we're going to create a test. We're going to test the add function. The only thing that's left to do here is actually go check our add function here. It exists in index.ts. So let's actually add it. Import add from index. And voila, we have our add function. As you can see here, it actually aliases A to number and B to number, which is unfortunate. But we're also working on a plugin to get this nice and working well. And now we're actually going to perform an addition. We're going to expect add of 23 and 19 to be 42. And then we're going to log hello world to the console. The next thing we have to do is we actually have to run the as-pect testing framework by running it from the command line using npx asp. And as you can see down here, it sort of churns a little bit. But here, as you can see, it says that our test passed. And it also logged out hello world to the console, which is great. So we know that it's actually working. If we wanted to see a little bit more information, we can actually do the verbose command. And what that will do is it'll actually show you each individual test and where the stack trace was for the logged value and that each individual test passed. So that's it's a useful feature for, at least for me anyway. As you can see, it ran here in like 2 seconds. It bootstrapped the compiler, compiled all the tests, ran the tests, and it was finished in less than 2 seconds, which is great. So yeah. I want to talk about some of the stuff that it generates for you as well. And here you can actually see a configuration file. Oh, I did not mean to do that. Oh boy. See if I can get this all back. Okay, can we see it still? Sorry about that.
Yep, you're good.
Okay, so here I want to actually go over some of the stuff that it generates. And here's the config. This is how we specify which tests need to be included. You pass it a glob. If you're familiar with the glob CLI, what this will do is it'll traverse all of the directories in the assembly and tests folder here and find spec.ts files. And all of those will become test modules. Let's see if we have any more questions. And here, we can actually specify if any additional files need to be included in our compilation. These come as include files by default. Any command line flags that you want to pass to the compiler when the compiler gets bootstrapped, you can pass them here. So here, we're actually going to pass this text file command here. And what this is going to do is it's going to output a text file that contains a text representation of the bytecode that it output. And here, this is actually where the module is instantiated. And you actually control how the module becomes a WebAssembly module right here. You have to call this create imports function. And then any of your imports, your WebAssembly imports, should go here. And the rest of it is not necessary to talk about for today. So here, we're going to make sure that a text file gets output, and we're going to actually see what our add function looks like. So npx asp, and the compiler runs, as you can see down here, and voila. Our test ran. It only cost us 100 milliseconds to output what's called a WAT file. And here, this is the text representation of the binary. As you can see here, this is a bunch of data segments that get written to linear memory to start. And these are all the imported functions that as-pect will use. There's not a lot here. Like, for instance, here's the clear actual function and the clear expected function. I'm just going to scroll through this rather quickly because I'm sure everyone is interested in the add function, which is what we're going to test here. So let's actually search for \add. Add memory. Here we go. Here's our add function. I'm going to highlight it here. As you can see here, in binary, we can say that the add function has 2 parameters, and it results in an I32 value, which means that that's the return value. When we actually want to perform addition, we pretend that there's a stack of values, and this local get operation will push that value to the stack. Then this local get will push the second value to the stack. And finally, an add will be performed where the top 2 values on the top of the stack will be added, and only the added value will be left on top of the stack. Finally, the value left on top of the stack will be implicitly returned as an I32. We can also see our test function here by checking to see here. This is exactly what I wanted to see. Here are the magic numbers that we put into our test. You can actually see the 23 and the 19 here. And both of those values will be added because we called the add function. Those are the two parameters on top of the stack. Then we call the expect function, and this becomes the actual value left on top of the stack. Finally, we'll actually perform the comparison to 42, and then there's a couple magic numbers here. These are all pointers to linear memory, for instance, some of the strings. After that's all done, it'll perform the to-be assertion. And then it'll log the string. See, the pointer to the string is actually here, the hello world string. And then finally, what will happen is it'll release the expectation itself. Remember, we had to create the expectation, and now the garbage collector has to come in and clean it up. This release function is very special, and what it allows us to do is it allows us to keep track the reference count of a given reference in linear memory so that it can be garbage collected later. Here's the name of the anonymous functions too. As you can see, they get aliased anonymous, but there's an anonymous function inside an anonymous function, and surprisingly, this is exactly what that is. Right here, the add functions. I just thought it would be really neat to go over what the WAT file looks like and how as-pect actually will compile the tests and what it ends up looking like. So I believe this is the end of the demo, and I'm happy to ask any questions and use this to actually show you what stuff looks like if you might prefer. Let's go back here.
Awesome. So yeah, people have been asking some questions. You did some live already. Feel free to jump in there and ask any questions for Josh. I'll go through more comments that I saw earlier and just call them out. Something cool said, oh, this looks like PowerShell's testing framework tester, and they're not surprised. We answered the one about the full mocking API. Someone enjoyed your 42 joke.
Yes.
And also seeing the source code was super helpful. Something cool also said, JavaScript and WASM are second languages to me, but this talk shows me that I need to better learn my native languages testing frameworks.
Yes, testing is the most important thing you can do for your software. You should definitely understand what your software means and make sure that your users, when they consume your software, that you're responsible for what you put out as a developer. Like, you should definitely do that. And that was one of the things that I was very cognizant of when I made as-pect. So yeah, and there's a couple little things that I wanted to go over, and I wanted to share the lessons that I learned in actually making the software. And a few of them were actually really surprising to me. For instance, building new software for a new language is super hard, and you're not going to have any good time to do it. You're not going to have a good time doing it. Let's see. There'll be plenty of pitfalls that you'll have to navigate. And it's much like the Wild West, which is kind of why I chose this particular GIF. It wasn't, oh, dang. My presenting software has been very fun tonight. You're going to find bugs, memory leaks, and garbage collection errors all over the place, and that was definitely the case. Oh, code coverage metrics? I believe so. I don't know how to hook into code coverage just yet because WebAssembly is complicated, and anyone who wants to help me implement it would be greatly appreciated. But I definitely want to do it. It should be under the realm of testing software, yes. So back on topic, building software for a new language is hard, and you're gonna pull your hair out in frustration. Oftentimes, I found that the language changed underneath me. For instance, the garbage collection algorithm that was introduced made AssemblyScript great, but because my testing software had assumed that it was impossible for garbage to be collected, I had to do a lot of manual freeze, and I had to rewrite the entirety of my software from scratch when that happened. So prepare to fight your compiler, and sometimes you'll just have to wait for features to come down the pipeline. For instance, code coverage metrics. I would love to do that. It should be done. One of the things that I also found out that my personality isn't so good when it comes to actually completing projects. And sometimes my arrogance got in the way, and I know a lot of people who I work with will definitely know that I tend to do that sometimes. I tend to become arrogant. But the thing is, if you keep your head level and you remember how far down the curve you are in the Dunning-Kruger curve, I don't know if anyone knows what that is, but the less you know, the more you think you know sometimes. So just pretend like you don't know things, and that should help you out on your journey. Now, I want to talk about this particular problem that I found, was that optimizing modules tends to be slow, not optimized modules, because when you optimize your AssemblyScript module, it's going to be a lot faster because a lot of the opcodes were removed, for instance. And binary N, which is the underlying layer that compiles to WebAssembly, does a very, very good job of actually optimizing your opcodes. But the process of actually performing those optimizations is rather slow. So when you bootstrap a compiler and then you compile your software, it's going to be slow if you decide to make it do a ton more work. And as a result, I found it took like 4 or 5 seconds per module sometimes to optimize my software. And that was in the earlier days of AssemblyScript. But nowadays, it's not so bad. And I also want to say that if you're making software like testing hash functions, maybe it does become imperative for you to actually optimize your test modules. And what that will do is it will allow the hash functions to run faster so that your testing can happen faster. But every situation is different. And what you have to do is you have to actually tweak the parameters you send to the AssemblyScript compiler in order to make sure that you know which is fast and which is slow. Another thing, you really want to truly avoid function inlining, because that will cause the compiler to do a ton more work that's completely unnecessary for testing. Chemo Crossman says, it appears very verbose. Will that be refined? I don't know what you mean by verbose, so I'll continue the topic. You can definitely type out what you want to say. One other last thing that I wanted to say is that JavaScript is really, really fast too. Like, it has a lot of good uses, and as a dynamic host for tests, it does a very, very good job of optimizing how things should be done rather than what should be done, maybe. And don't count JS out, because it definitely has its purpose. AssemblyScript does a very good job of optimizing heavy loads. And sometimes your application isn't necessarily a heavy load. You shouldn't just write your whole application in AssemblyScript. You should definitely use it for what it is, and it's a tool. Let's see. I also advocate for not writing code you aren't proud of. A lot of the times I had trouble writing as-pect were because I decided I wanted to implement a feature that I didn't like and that I didn't think actually fell under the realm of testing software. So one of the things that I definitely want to do is make sure that my software does the features that I expect them to do. So for instance, as-pect, because it doesn't like to optimize modules, shouldn't be doing performance testing. That should be left up to a completely different tool. And I haven't actually created that yet, but I do want to create a performance metric tool later. So that's a good example. Just make sure that you have a game plan, you talk to your users, and then figure out underlying problems and fix those. Don't assume that your user has the answer to your problem by fixing this one little thing. Be confident in yourself and understand what you value as a human being first before you start making your changes. And this is the last one. I really want to make sure that I take help gracefully. This is one of the most important things to me right now, is because I don't do that. And I know developers who are really stubborn who definitely should learn how to take help gracefully. There's lots of smart people out there, and they want to help you. And they are definitely smarter than you are in a lot of different ways. Take their help and be the best developer that you can be. That's definitely what I'd like to say. So thank you all for watching my talk. I had a blast doing this, and I hope that everyone learned something. And I can field questions now. Please pop them in chat.